Hello and welcome to the breakout session. I'm Alvian with my co-speaker Dipanshu. We're from the Gojek mobile team. Today we'll present on how we measure mobile application performance at scale. There are three key takeaways from this session. 1. Define mobile app performance metrics. Second, data pipeline and observability. And finally, page performance score system. Let me begin by giving you some background and insights about Gojek. Gojek is Southeast Asia's leading on-demand platform and a pioneer of the multi-service ecosystem model. We offer a wide range of services from mobility, food delivery, and logistics. We operate across main cities in three countries: Indonesia, Singapore, and Vietnam. As of September 2021, we have more than 2.5 million driver partners and more than 1 million GoFood merchant partners. In 2020, Gojek contributed 249 trillion Indonesian rupiah to the national economy. It is equivalent to 1.6% of Indonesia's GDP in 2020. At the time of this presentation, 1 USD is around 15,000 rupiah. And from the engineering perspective, we run one of the largest JRB, Java, Clojure, and Go clusters in Asia. We process more than 350 million internal API calls per second. We also love to contribute back to the tech community, and we have open sourced many of our tools and libraries. You can check them at the Gojek's GitHub page. So, next, what is the importance of mobile app performance? We have gathered data from App Dynamics and dimensional research between 2015 and to 2021. The result can be categorized into three main categories. First, user experience. So, based on the study, it found that 93% of users expect reliable and consistent performance of the mobile app. And 49% of users expect your app to respond in 2 seconds or less. Second one is customer retention. 55% of users will hold your app responsible for the poor performance, not their device or not their network. 63% of users actively try to discourage others from using a service or brand if they have bad digital experience. And third, business growth. The percentage of users willing to pay more for an app that outperforms its competition grew to 50%. So, based on these numbers, it's clear that app performance is one of the critical factors for delivering a delightful mobile app experience to customers and for the growth of the business. So, what are the metrics we use for measuring performance in a mobile app? There are two main metrics. First, app launch time. This is the user's first experience when opening an app. It is the time they need to wait before the app is ready to be used. It's very critical because a long launch time will delay the user in performing a task, which may frustrate them. Second, page performance. It's measure the performance of screens in customer journeys to understand how the app is currently performing. It can be divided into two sub-metrics, initial and post-load metrics. Let me provide you an overview about these two sub-metrics in next slide. So, how do we define initial page load time? It is the amount of time taken for a screen to render the content and become interactive to the user. It starts when the user navigates to the screen. We call this time to initial load, TTIL. We can also break down the TTIL to several granular metrics. First, dependency injection. It is the time taken to resolve and inject all the required dependencies for a screen and its related components, such as maybe view model, presenter, and many more depending on the architecture of your application. Second is the time to first layout, TTFL, measures the time taken from the screen initialization until the first layout content is rendered. Usually it's a shimmer or any view that represents the indeterminate loading state. And we have the content fetch and content render time. Content fetch time is the time taken to load the content from a network remote API call or maybe from local disk cache. It also includes the time taken to decode the raw data into the data objects. And content render time is the time taken for the view to render the content of your screen. In addition to the initial load page metrics, we also measure post-load page metrics as users interact with the page, such as scrolling, animation transition, or tapping a button. We divide this into three sub-metrics. First is slow frame. This metric is the percentage of user sessions that experience a noticeable amount of slow rendering for a specific screen. Specifically, the metric is the percentage of screen instances during which more than 50% of frames took longer than 16 milliseconds to render. Second, frozen frame. This metric is the percentage of user sessions that experience a noticeable amount of frozen frames for a specific screen. Specifically, this metric is the percentage of screen instances during which more than 0.1% of frames took longer than 700 milliseconds to render. And finally, we have image load. To measure the performance of image loading in a screen, each image view starts to measure the time taken to request an image to the server or API, or maybe the disk cache, until it is converted to bitmap and displayed to users. We include various attributes such as screen, component, response size, request width and height, and various other attributes. So that's it for the initial and post-load page metrics of the page performance. Next, let me hand over the presentation to my co-speaker, Dipanshu.
Thank you, Alfian. And hi, everyone. This is Dipanshu, and I'll be taking forward from here. In the previous slides, Alfian has explained what all metrics we use for measuring mobile app performance. Now, let me take you through how we capture these metrics and design the data pipeline flow so it can be monitored from a dashboard. As you can see in the diagram, the mobile client first captures traces using Firebase Performance SDK. Next, Firebase performs a daily batch export containing all raw data to BigQuery. Then we use our open source tool known as Optimus to schedule a daily job to aggregate the Firebase raw data to summary tables in our BigQuery cluster for data warehousing. And finally, we use Grafana dashboard to query summary tables and display the performance metrics for our stakeholders to access and monitor. Let's deep dive into each of the steps in the next slides. For mobile client tracing, we utilize Firebase Performance SDK's custom tracing feature. Using Firebase Performance SDK, we have created our own framework for each platform, which provides implementation for capturing metrics for the page performance. To minimize the performance impact due to trace collection for users in production, we use random sampling to decide whether we should collect the trace or not for a particular session. This random sampling value is controlled by our remote configurations. Firebase SDK also provides built-in automatic capturing for frozen and slow frames for an activity or fragment on Android and UI view controller on iOS. In addition, it also captures traces from the network API calls for both platforms. Next, let's talk about data aggregation and warehousing. As we build a custom unified dashboard to display our metrics, we need to export Firebase performance traces into a data source which we can use to query. Firebase provides BigQuery integration that will run a scheduled daily batch job for exporting all the traces to the BigQuery table at a scale of users. Querying the raw data from the dashboard directly from this table is very costly and time consuming as the data is quite huge. To avoid this huge cost and query time, we utilize an open source orchestrator for data transformation and warehouse management at scale called Optimus. Gojek is one of the main contributors for this project. We simply need to write queries to aggregate and batch the raw data into summary tables and schedule the job to run on a daily basis. We aggregate the traces using percentile scores from P50, P90, and P95. Using percentiles provides a better visualization on how the numbers are distributed across the group. For example, with P90, we are able to know the number distribution for 90% of our users, so we can optimize for the remaining 10%. The next part we'll go through is dashboard and monitoring. For the dashboard, we use one of the most popular open source dashboards, Grafana. It provides a wide range of built-in graphs that we can use to visualize the data over a series of time. Grafana itself doesn't provide BigQuery as the data source out of the box, but any data source can be added using a plugin. We use the official BigQuery plugin from Intel to add BigQuery as the data source so we can write row SQL queries to retrieve the data from BigQuery. For alerts, we define the base thresholds for each panel and use Slack to post the alerts in case the value has exceeded. We deployed this dashboard internally so it can be accessed by our stakeholders. Let me show you the illustration for the dashboard panels in the next slides. This is the page load time dashboard, also known as time to initial load for a screen. It shows three lines representing P50, P90, and P95 values of page load time for a particular screen. Next is the dashboard containing the granular traces such as dependency injection, time to first layout, content load time, and content render time for a particular screen. Next, we have the dashboard for screen responsiveness, showing panels for frozen frames ratio and slow frame ratio for a screen. And finally, we have the image load dashboard showing panels for overall time taken to load an image, time taken to get an image from disk cache, and time taken to fetch an image from network. We also have a panel for showing the response size of images for a particular screen. Next, we would like to talk about page performance scoring system. Page performance scoring is a scoring between 0 to 100 that we use to measure overall performance of a screen using multiple metrics from real users in production. Page performance score uses multiple metrics like time to first layout, time to initial load, slow frames, and frozen frames. Calculates the score given the formula and weights each matrix into one single score. The page scoring system has been used by other apps as well. For example, Airbnb published a blog detailing their page performance scoring system. The underlying mechanism itself is a quite similar to Google Lighthouse for measuring the performance and quality of web pages. For each metric, we calculate the data into a single score from 0 to 100 using log normal curve distribution. We simply define the median control point and P10 point using the threshold that we want to achieve for each platform. After we get the score from each metric, we sum the metric score into one final value based on the weight of each metric. Next, we have the dashboard for showing the page performance score. Yeah. Here we have the panels for the latest page performance score, weighted score distributions, and the score history over a series of time. Next, Let's talk about the benefits we have gained so far by performing this exercise. With the measurements, we have been able to understand the performance data for our current users. It helps us to set the baseline and thresholds going forward as we add improvements. As we add features to our app or release a new app version, we are able to catch any performance regressions as soon as a new app version is released. Also, we are able to monitor improvements made in new app releases. With the data available in our BigQuery tables, we are also able to archive the data for long periods of time. So, what's next in our pipeline? The current way we aggregate the data takes around 2 days to be reflected in our dashboard because the raw data is exported in a daily batch to BigQuery. So we want to make this monitoring real time. We plan to achieve this by using Clickstream, which is an open source tool maintained by Gojek for real time analytics data injection. Finally, we want to make the performance measurement as a part of CI/CD pipelines so we can catch performance regressions early during the development lifecycle. That is it for the session. Thank you everyone for watching and have a great day.